All right, equations of circles. Identify the center and radius of each, then sketch the graph. The center is +1, -3. 1, comma, -3. The radius is 2. And so we go 1 to the right, 3 down. Just like that. And it will be the circle of radius 2 with that center. Like that. Here. 2, comma, -1. The radius is 4. 2 along, 1 down. A radius of 4. Something like that. Something like that. 1 arc there. Another arc there. Another arc there. Another arc there. These are just sketches. The center is 1, comma, -4. The radius is 3. So 1 to the right, 4 down. 3. Puts the points on the circumference like that. Oh boy. Like that. There. Center. In this case, 0 for the x coordinate, 3 for the y coordinate. And the radius is √14. Is between 3 and 4. And 3.5 squared is 12.25, 3.6 squared is 12.96, 3.8 squared is 14.44, and 3.7 squared is 13.69. So it's about 3.7 or 8. Anyhow, 0 along and 3 units up. So the radius will be a little bit under there, a little bit above there. That would be further down actually. A little bit there-ish and there-ish and connecting. Oh boy. Anyway, like that. Okay, so this isn't in the HKR form. By HKR I mean x minus h squared plus y minus k squared equals r squared. That's a typical form for a center. So I need to make it in that form. So I'll use this space here to rearrange things. Put x squared over there. Put it next to 4x. Put 2y there. And 20 on the right. Okay. Oh, sorry. Beg your pardon. Y squared next. And -2y there. And 20 on the right. And now factorize, or complete the square rather. So x plus 2 all squared. And then y minus 1 all squared. This will contribute a 4. This will contribute a 1. So I have to subtract 5 to balance that out. And that -5 there will be pulled over to the right, giving us 25 on the right. So it's a circle with a center of -2, 1, and a radius of 5. So we go -2, 1 there. Radius of 5 out to there, to there, to there, and there, and draw. There. Okay, for this one here, multiply everything by -1, and thus the center is the origin. The radius is the square root of 9, which is 3. So there, 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 and there. Circle round. A little bit better than that. Something like that. Okay, here, multiply everything by -1 again. So we're going to get x squared plus 6x plus y squared minus 2y equals -9. Good. Complete the square. Like that. This contributes a 9. This contributes a 1. So we have to, so together that's 10. We have to take away 10 and then add on 10 to the right hand side. So 1. So it's going to be the circle that has a center of -3, 1 and a radius of 1. So -3, 1, it'll be there, and it'll be a real tiny unit circle like that. Finally, this one here, x squared minus 8x next to each other, y squared minus 6y next to each other, minus 16 on the right hand side, x minus 4, square that, y minus 3, square that. This contributes a 4, this contributes 16, this contributes 9. Together that makes 25. That has to be taken away from the right hand side, I guess. Giving us -41, so no circle to chart. Use the information provided to write the equation of each circle. All right. Center is 13, -13, and the radius is 4. So we write x minus 13 squared plus y plus 13 squared equals 16. Here, right, this. Okay, now we have to figure out what the radius is. So we find the distance between these 2 points, and the way that we do that is we do x2 minus x1 squared plus y2 minus y1 squared, and then square root it. So the difference here is 0, the difference here is 3. That squared is 9, square root that is 3. And so the radius is 3, and therefore we write 9 right there. The ends of a diameter are as follows. Okay, so find the midpoint of these, and that'll tell you the center of the circle. So the center is 11, comma, -8, like that. Then find the distance between them and half it to get the radius. So distance between the x values is 14. distance between the y values is 10. So 196 plus 100, that's 296. Half that to get, you do half it, right? Oh no, you have to square root that and then half it. Like that, and that'll give you the radius, I believe. Okay, so what goes into 296? Well, 4 times 74. So 2 root 37. Okay, so root 37. That's the radius. And so I'm going to write 37 on the other side. I'll just try it. Okay. Center is that. The tangent to x equals 13. Oh, it's tangential to x equals 13. So if x equals 13, that would be a vertical line at 13. And thus it will pass through there at some point. Okay, so point on the circle will be I see. This. That'll be a point on the circle. And okay, so the radius is 3. So center lies in the first quadrant, and it's tangent to x equals 8, y equals 7, y equals 3, and x equals 14. Okay. So mental picture. There's x equals 8. There's y equals 3. And so the circle will be something like that. Uh, 8 and 14 block it on both sides. So 8 and 14, that's 22. 11 will be the coordinate, the x coordinate of the center. As for the y coordinate of the center, well, the gap between them is 6, is it not? And therefore the radius is 3, and therefore it'll be 3 and 3, so 6. That's the center, and we need the radius. The radius is 3, and thus we write plus y minus 6 squared equals 9. The center is this, the area is this, and so we need to work the formulas backwards there. And so this is the square root of a over pi, which in this case 25 pi over pi is 25. Root that, you get 5. So radius is 5. So it'd be x squared plus y minus 13 squared equals 25, just like that. And we're going to check all this. Yeah, that's all accurate. Okay, okay, there's a miscalculation here, but where? All right, we do that, put that there, 16, 9, together, 25. Oh, that has to be taken off and then added on, darn it. Okay, add that on. So radius is 3. All right. 4 to the right and 3 up. There, 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 and there. Yeah, that's better. Okay, that one's correct. That's correct. That's not quite right. Okay, figure it out. Okay, those are the ends of the diameter. So 14, so 196 and 100 is 296. And so the radius is root 296. And that does have to be divided by 2. And so it's 4 root 74. 4 root 74 over 2. No. Is that right? Yes, it is right. 4 root 74 over 2. So perplexed. Right, we need to slow down. Okay. 14 squared, 196. 10 squared, 296. Add them together. Square root. I'm absolutely positive the diameter is that. So the radius must be this. 296 is root 4 times root 74, which is 2 root 74. And thus this cancels down to root 74. Okay. So I understand now why it's 74. All right, fine. That's correct. That's correct. And that last one is correct. Okay, done. Brilliant. Okay, looking at, we'll do translation first. Usually the simpler sort of one. Okay, translate the figure. 5 units right and 1 unit up. Okay, so G goes to here and here. There. Here, 1 unit to the left, 2 units up. Three units down. 5 units to the right, 2 units up. Four units right, 4 units down. Two units right, 3 units up. Okay. And here we go. Write a rule to describe each transformation. Okay, I'm going to use vector notation. Here we go. And of course, I have to do all the vertices, but with a prime symbol next to them. So, there. Right, all done. Check. Okay. Correct. 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 Yep. 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 That's all good. All right. Okay, rotations next. Rotated 180 degrees about the origin. All right, so what will that look like? Okay. B goes there. Where does K go? There. Where does N go? Instead of being there, and goes there. And finally, where does F go? There. Okay. Okay, 180 degrees about the origin again. Okay, so where does V go? There. Where does J go? There. So there's V, there's J. Where does R go? There. Where does Y go? That's what I believe. Rotation 90 degrees counterclockwise about the origin. Okay, so this time we'll slow down and we'll point out where B goes. B prime, X prime, N prime. "90 degrees clockwise." There's my new B. And U. There. 90 degrees clockwise about the origin. Okay. No, wrong. Again. Okay, V becomes there. K becomes there. J becomes there. And join. Now rotate 180 degrees about the origin. All right. So P will become there. Then, no, that's not quite right. Okay, there's K. Q. And there. And T. There. All right. Okay, so okay. 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 All right. Yeah, of course, that doesn't matter. Okay, that's good enough. Fair enough. Fine enough. Okay. Reflections now. Okay. 12 of these. Graph the image of the figure using the transformation, giving reflection across y equals -2. Okay, so we need the points. So y equals -2 is a horizontal line around here. Okay, so there, and q will be there, and z, I can't really tell what letter that is, will be there-ish. That seems fine. Connect it up. Seems fine. Reflection across the x-axis. Okay. No, wrong. Just trust your eyes sometimes. No. That's just not right. Reflection across the x-axis. Hello. There. Good enough. Y equals -x. Okay. Okay. Good enough. Flexion cross y equals -1. There, and flex across it. So that's going to be there, that's going to be there, that'll be there, and that'll be there, and then connect up the points like that. Flexion cross x equals 3. So first make x equals -3, which is that line right there. Then chart the points. There, 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 and there, and connect them. Like that. Cross the line y equals x. Make the diagonal. Get the points. That one. That one. That one. And that one. And connect. That's fine. Now write a rule. Okay, K is now there somehow. So the line of reflection, the red line of reflection, is that. Like that. Like that. Reflect across. There. Y axis and reflect across y equals x. And check. Okay. All good. All transformations combined. All right. Okay, rotation 90 degrees counterclockwise about the origin. Okay, 90 degrees counterclockwise, so Z will end up here. J will end up there. Oh, yeah, of course, that makes sense. And L will end up there. Translation, 4 units right and 1 unit down. One unit right and 1 unit up. Okay. Reflect across the x-axis. Get the points. Write the rule to describe each transformation. Reflect oh no, that's not a reflection. Hold on. Oh yes, it is. And this one. Graph the image of the figure using the transformation given rotation 90 degrees clockwise about the origin. Okay, so what you do is you do the figure first. So b is -2, 0. No, a little bit too thick. C is negative, call that b, -4, 3, -3, 4, -1, 4, and connect it. And then rotate it 90 degrees clockwise about the origin. Like that. Graph, draw the image. So k is -5, -2. A is -4, 1. I is 0, -1. J is -2. -1. And that has to be reflected across the line y equals x. There we go. There, and k. them. There. Find the coordinates. Okay, this is what I really like. Find the coordinates of the vertices of each figure after the given transformation. Rotation 180 degrees about the origin. Okay, so I have to think. So how does it go again? Two, three up. It becomes 2 down, 3 right. That becomes 2 left, down. So 2 right, 3 up became 2 left, 3 down. So you literally just make them the negative of what they are. Isn't that so? Yes, I think that's so. Okay. So in that case, reflection across y equals 2. So think about how this works. Y equals 2 is a horizontal line like that, and the y coordinate does not change, but the x coordinate, however far away it is from 2, it becomes that far away in the contrary. Okay, yeah, I get it. So that'll become 3. That'll become 4. That'll become 3. And that'll become 1. Translation: 7 units to the right, 1 unit down. Okay, so add 7, take 1. So translation: 6 units to the right, 3 units down, add 6, take 3. Okay, and check everything. Check everything. Mm-hmm. 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 Okay, I got that. I didn't get that, though. Why not? Okay. Right, this one. Must understand it. These are correct. These are correct. All right. So what's going on with this one? Oh, no. Okay, they did it in a different order, first of all, which is weird. They changed the y coordinate. Why is that? Oh, it's the y coordinate that changes, of course. Again. Okay. 1. That'll become negative 1. That'll become negative 1, and that'll stay fixed. Okay. All right. Okay, so that's all been sorted out, including the equations of circles. And all that's left is something that's quite unrelated to geometry, but I'll do it for completeness sake. We'll have a look at it. Okay, that'll come next. Be well.